Hello, this is another tutorial for the TPS Timber Plate Structures plugin, which you can download for free on foodforrhino.com. This time I'm going to focus on the fabrication of the structures that you can generate with this plugin. So first thing I'm going to do is to open the example number 1, diamond, which is a basic surface on which we can now apply the Grasshopper example file, example 1a, diamond miter joints. And you will see that now we are automatically generating 3-dimensional plates for each of the facets on this mesh. So there is a base mesh generated here. It's a component that you can select from the TPS menu up here, TPS diamond mesh. And you can change parameters. I've shown this in the other tutorial already. Now what you get from this is these plates over here, which are also updated live while you change the shape and the number. They're going to change accordingly. So let's say you have found a configuration that you like and that you would like to fabricate. What you need to do is you go to the polyline output, and with a right click you can go to the bake option and you can generate some polylines out of this geometry. Now I can close this, or actually I'm going to open another example file, example 4 G-code, because this is now what lets us turn this polyline geometry into fabrication code that we can send to a CNC machine. Now the CNC machine is going to typically have a table on which we can do the milling. So now let's say this table would be something like 1500 1.50 m by 2.50 m large. So now this would be our machining table. So the first thing we're going to do is I'm actually going to move all of this a little bit aside. And then, okay, let's maybe grab some of these elements. I'm going to get them over here. And maybe we can rotate them to fit them on this table. Okay, so this would be a sort of realistic setup for cutting something. And now there's one more thing that we need to check. It is important that the lower contour, so these are basically plates defined by an upper and lower contour. And we need to make sure that the lower contour is also on the world 0 plane. So I'm going to select these. Use the vertical move option and move them so they are really lying on top of this cutting table. Okay, so this is where we now can really get to the fabrication plugin. It's using this component here. It's called TPS Loft Cut. It's got this icon here which shows it's about 5-axis CNC milling. And the most important input here is the curves input, which takes the contour polylines. This is what we have here, which defines what we want to cut. And these polylines, they're basically defined by sets of points. And it's important to understand that each of these polylines, it has a start point, an end point, and it has a direction. we can actually use the direction command in Rhino to display this. And now you will see that we have here the start and end point, and we have a counterclockwise direction on this curve. This could be reverse, so it could be looking something like this, or it could be actually looking something like that. Or it could even be looking in a way that the start point of the top curve is here and the start point of the bottom curve would be here. And this would be bad because this plugin requires nice geometry. So the start points of these curves, they have to be synchronized correctly. And also there has to be the same amount of segments in these polylines. This is something that you can check if you go to the properties. I'm going to drag this over here. And then if we go down to details, then you will see the object description of Rhino. And it's going to tell us, especially if we only select one curve, that this curve, it has 7 points. We can check it for the other point curve. It's the same here. So this is quite important. We need to have the same amount of points. This could also be checked by turning on the points of the curve. There should be no duplicate points. So this is all looking very nice. If we had the situation where the start points are not looking the same, this can be changed with the curve seam command. With this we can actually change the start point of the curve. I can put it here. So now if we would go again, we would use the direction. Then you see the start point has moved. And in this case now we would actually have to use, in order to fix this, the curve seam command. It is automatically making a suggestion for synchronizing these points. I can accept this. And now if we take another look, it's looking good again. Okay, so this is something that needs to be checked. If you're doing the generation of your polylines with an algorithm, then this is always going to be exactly as you have programmed it. If it's coming from a manual process, it's a lot more likely that you're having to do some cleanup work after. So now, since we have checked that all of these are looking good, we can select them and we can go to the contour polylines input of the plugin, right click it, set multiple geometries. And now we're seeing a lot of things happening. So the first thing we see is this red line, which is showing how the center point of the tool, the so-called TCP, is going to move once the CNC cutting starts. So this is basically the path that this tool is going to go when it cuts these parts out of the plate. And if you look at the details, there are some slightly more complex things happening because this is all oblique cutting, 5-axis cutting. Then there is some points where it actually has to lift off from one part to another part. And in some cases there are also some parts during the cutting of one part where it has to lift off and reorient. We are not having this here right now. You also see that's 2 passes, so it's going to cut only half of the depth of this material, and then it's going to do another pass cutting down all the way. This might be important because you have to take a look at your tool parameters. How much can you cut in one go? How fast can you cut for this depth of cutting that you cut into the plate? So for some materials, for some plates, it might be that you cut this in one pass. For some others, you might have to do 2 separate passes. So this would be the tool path, the preview, which you have with this component here. It's the TPS draw G-code component. And you see we have a second component down here, which is actually giving you a simulation. So what this does is it has a position slider. The position slider goes from 0 to 1, and this corresponds to the lines of the CNC code, the so-called G code. Position 0 is the start position of this program, and position 1 would be the last number in this program. So by moving the slider, you see that we can actually see exactly how the machine is going to be cutting this. This is the second pass of the first part. It's going to lift off. It's going to do the second part, the first pass. And now for each of these points, we could actually put the machine right here. And then we could take a close look. Okay, what's happening here? Is there potentially any collision? This might depend on the tool parameters, the length of the tool, for example, which you can also adjust here. The radius. So this is maybe also something interesting. You can do this dynamically here. The tool radius is defined in millimeters. So if I would be changing that right now from a 6 millimeter radius, for example, to 8 millimeter radius, you see this is happening right away. And it is going to affect the G-code output, this program here. And at the same time, it affects the preview of your TCP, and it affects also the simulation output. Your machine on which you might be cutting this finally could look different from this one, although the most critical questions that you're typically asking is if it's going to collide with your tool holder. And this here is a 63 millimeter tool holder, which is a very common tool holder. So this should be very close to the setup that you're looking at if you do this milling with timber plates. The same applies for the code that comes out of this here. You see it's commented, so it explains a little bit what goes on. Like first security point, it's going to dive. Otherwise, this is following the G-code standard. So it has these G0 for rapid movements and G1 for cutting movement positions, followed by X, Y, Z, and AB values, which describe the point location for this point in the program, and the alignment of the tool with its two cardanic rotations. Finally, we're having here this F value, and this is the feed rate, which is millimeter per minute. So this would be 2 meter per minute feed rate for a vertical motion. It is also going to tell you when it goes into second pass. So here you see start in feed number 1, that's the first pass, and for this part there's going to be no second pass. Oh yes, because it's counting down. So it starts with the clockwise pair number 2, and then it starts with the in feed number 2, and then it counts down to the last in feed, so number 1 is the last one. So that's how that works. Okay, so maybe one last thing to show is a really interesting feature of this plugin is the ability to cut concave contours. So I think this is something that's shown quite nicely with the example that comes with it, example for G-code. And at the same time, we're going to open the Rhino file that belongs with this example. So you see this is a lot more complicated plate geometry, which has these concave contours, which means out here at this corner we have a convex shape. But then once we get into these dovetails, there are concave corners. And with a cylindrical tool, which we typically have, we cannot really make these sharp corner cuts. So what the plugin is going to do, I'm going to select, show this these two contours. And you see that it is doing these funny things over here in the corners. And if we would now use the simulation to understand better what goes on, we can see it right here. The tool is actually cutting further into the corner. So this is the point where it goes down to the notch point. You can see that it becomes tangential here, which means that the center axis of this tool, it is now in the exact position that makes the cylinder surface tangential to this corner. And that means it's going to cut away just enough so you can fit the other part in here and no more than necessary. And it also will automatically go deep enough to make sure that you're cutting away enough material here so you can fit in the other part all the way. This is something that is controlled with the notch option of the plugin. This is something with a right click you can access here the Boolean value. It's set to true here, which means do cut these notches. This could be set to false, and then you see these notches, they all disappear. So now you would be cutting this with no notches, which would mean that afterwards you could not insert the other part, but you might want to use this option. For example, for cutting a pre-pass, you might want to use a thicker tool to cut a first pass, which cuts faster. And then you do a second pass where you use a smaller tool and it's going to cut all of these little notches. Okay, so there are a lot of more parameters here which are more or less self-explaining. You can change the cutting speed. It's separate for horizontal and vertical movements. Number of vertical passes to cut. So if we would go here and we would say we want to cut like 5 passes here, then this is what you get, right? It's going to cut 5 times. It's going to take a long time. But you might want to do this if you're working with a sort of delicate machine which cannot take a lot of forces. So you have to do more passes. And these values here, the safe C height, it means the machine is actually going to move away from the workpiece in exactly the direction that you see here along the axis, until it comes to the Z height that you define right here. And there are 2 different values, because the upper one is when it is going to move away inside a part. It will sometimes have to reorient, like here. And it needs to move out of the part, but it doesn't need to move out very far away, like here. Because if it moves from one part to a different part, like from this one to that one over here, it's going to travel across the entire table. And in this case, you might want to move further up, because you might have some clamps here on the table, and you don't want to hit them. So you can put a higher value here and a lower value here, because this is basically not moving around the table. It's just moving at least above the plate. So if your plate has a thickness of 50 millimeter, then you want to do at least something like 70, 80 millimeter here. Okay, so finally, the G-code is something that you could save to a file with the stream contents option, for example. or you could use the copy data option and copy it into a text file. Also, there is the option to use this code directly with the KUKA PRC application. For using this, you would have to get in contact with the authors of this plugin. Okay, so I hope this explains how you can use the fabrication options. Let me know if you have any questions, and thanks for watching.